All right, so in this video, we're going to be continuing our lesson on the definition of engineers and the general introduction to what an engineer needs to know and what they do on a daily basis. So today we'll be going over the types of knowledge that a engineer needs. So we've kind of touched on it a little bit that you needed math and science to be able to be an engineer. But as I said, we go a step further and we actually do things with that knowledge. So a lot of times you actually need technical knowledge. And in the classroom, when we're face to face, a lot of times that technical knowledge involves actually using tools and software to apply the knowledge that you're using. And a lot of that technical knowledge is also specific to the industry that you may be in. So, for instance, we've already said, math, algebra is universal, science, physics, universal concepts, gravity is a universal concept. But for a mechanical engineer, that technical knowledge, you may be using that algebra and physics to work for, like a General Motors. So you could be in automotive, or you could be working in aerospace for a Boeing, or like myself, working in oil and gas. So that's where that technical knowledge comes in. It's where you're applying the lessons that you learn in school to solve technical problems for a specific industry. So again, that mathematical knowledge, it comes from that analysis of data. So what's pictured to the right is something that civil engineers do. So you can see that's a concrete block. So they're applying force to it to see what kind of load that concrete block can take. So they're taking a look at the shape and the composite material they use for the concrete, and they're going to be analyzing data to figure out where exactly did it start to break first. What do they need to do to reinforce that that area, or if they need to use a different kind of composite mixture to reinforce the entire concrete block to see where it actually failed. I'm often because y'all are students and you're young, you're so reliant on your phones. It's also like the drop test. Although most of us drop our phones and it cracks almost immediately. I've cracked so many phones. They do test dropping the phones from different heights to see what can they do to keep it from shattering so easily. Although the rounded curves are very pretty on the phone, the rounded curves actually serve a function, because if all of the curves were perfect right angles, when you drop it, that the data would show that is a point where it's likely to break and crack. With algebra and calculus and then statistics, those are all things that you do. Statistics, is part of that. How often is it going to fail? The probability that it's going to fail. So that's where that mathematical knowledge comes into play. The scientific knowledge. So we're going back to what I was saying in where you're actually applying that understanding of math and using more intense, specific equations. So now you're using an algebra, but you're using specific algebraic equations to understand how things are working. So in that previous picture, I went over statics, force, load, tension. So tension is when you're pulling something. Load is just that weight. The force is the pushing, and then statics is when something's just in equilibrium. So it's just standing still. What are the forces that are acting on it? That next bullet we'll be getting to when we start talking about electrical engineering. Ohm's law is how resistance, voltage, and current reacts with each other. The atomic structure of the different atoms and chemicals that you'll be using, and then circuit theory. So how do the components that we put into a circuit interact with each other? Thermodynamics is part of how heat interacts to make things happen for the vehicles that you're building. Kinematics is motion. Fluid mechanics, gas, heat, air. So how do you use those things to move, to cause motion in environments? And then Boolean logic. Boolean just means that it's either 1 or 0, yes or a no. Your light switch all are Boolean. It's either off or on, except with the case of dimmers that I won't get into right now. It's basically either off or on. Dimmers just kind of, it's on, but it regulates how much of the voltage is actually going through. But it's still just off and on. So the technical knowledge, as I said, design tools in this class is Autodesk Inventor. So that is what we use to design. Some of the mechanical tools involve the Vex Robotics kits, screwdrivers, Allen keys. What else do we have? The ohm meters, voltmeters. So all of the physical things that aren't software in the computer that we're going to be using in the classroom are the mechanical tools. And then communication tools, just how you communicate with your team. So spreadsheets, emails, when we're doing project management. So when you have a longer project, some of the larger robots that we'll be doing in class, or some of the more advanced designs that we'll be doing in the spring, you will have a Gantt chart. So that's where you're communicating to your team and to me what you plan to do to stay on schedule for your project, to make sure that you're turning things in on time, as well as an engineering notebook where you're keeping track of your hypothesis, the things that you're working on, and your day-to-day management of your different projects and assignments. So skills and traits, problem solving ability, we've gone over that a couple of times. That's what an engineer is. It's solving problems. There's always new problems, no matter what product you create. As you create new products, you create new problems and new opportunities to solve it. Detail oriented. If you going back to the phones, somebody designed I don't even remember what year it was or what brand what do you call it? What model it was, but there was a model of the Samsung phones that were catching fire under the beds. That's, that goes into that detail oriented. Are you, paying attention to the things that you're designing? And they probably also went in at statistics. That means that somebody somewhere probably saw that this could happen, but the probability of it happening was low. So they went ahead with it. That's a trade-off, and said they'll deal with the lawsuits if they happen, and they happened. Analytical is numbers. Being able to be creative. As an engineer, you have to come up with creative solutions. Sometimes what you think should work in theory or what you've learned in class won't actually work in this environment. So you will be asked to think on your feet and come up with a creative, out of a box solution to to solve the problems. The drawing and design skills, you don't have to really be great with an actual pen or pencil. What you have to do is really understand how to manipulate software and communicate through the drawings, the prototypes, and what you want to be able to accomplish. Interpersonal communication skills. Engineers are often also salesmen. You have to present what you are creating either to your team, to your manager, or to a customer. One of my best friends, who's actually still with Schlumberger, he's gone through those phases where now he's what's called a product champion, where instead of being in a cubicle designing like we were when I was there and we were working together, he now travels around the world, and instead of designing the tools, he goes out to the oil rigs and he tells people, look, this is the tool that we've developed. It can do this, it can do this, it can do this. It'll save you this much money, and you'll increase your profits if you use this instead of the tool that you're already using. And then time and project management skills goes back to what I said previously about using that Gantt chart. So that's the end of the video for today. Head back to Schoology to complete the tasks that are assigned to you after this video.